Another way of looking at that whole concept is this schematic here. Let's assume I can put a light source that actually has a shape of a plus sign here. I have an opening with an aperture, which is much bigger here. When light goes through here, basically what's going to happen, as we've discussed in the case of the tree, it's going to get a little blurry. Similarly, if the hole is small, it'll be less blurry. Another whole instance of this would be is when we actually have a point light source. This is not a point light source. These were, had different shapes in it. A point light source basically has no dimension. It's just a very high intensity beam. When it hits this point here, because if it's a very small one, it's going to go through correctly. And of course, there will be no kind of diffraction patterns here. But if I made it even so much smaller, related to the wavelength of this light source, it's going to start creating diffraction patterns. So of course, we'll have another whole artifact on this image. So in essence, what it comes down to is we need to figure out how to control the various types of things in this image, which basically suggests that a larger pinhole, which is right here, creates geometric blur. A smaller pinhole would create a diffraction blur. So this is geometric blur, a diffraction blur. And a best pinhole basically would be an ideal in creating the images that we want, but of course will let in a lot less light. We haven't actually discussed the whole concept of amount of light, but it should be obvious. The smaller the hole, the less amount of light will pass through it. So again, let's look at the whole concept of pinhole size, and let's try to study it with a little bit of math. Let me get a few terms across. First term is d, which is the diameter of the pinhole. Again, we've also referred to that as the aperture, the size of the opening, because the amount of light goes through this one. Another term we'll use is f, which is the focal length, which is the distance from the obstruction, where the pinhole is, and to the screen or the sensor. How far away should that be? Because that's where everything is going to be focused and best produced. Let's call that f, and it's also referred to as the focal length of a camera. Another parameter we'll use is pi, which is basically the wavelength of light. So in essence, this captures is the the physical characteristic of the light itself. Using this, we can come up with an equation which suggests that the size of the hole depends on the focal length, how far I want the subject to be, or the image to be captured, and the wavelength in this form of an equation here.